Hello, this is Professor Kuehn. Let's work through some of the problems from AP Physics. Let's first work on the automobile problem. So this is problem number 1, the automobile problem. And how do we solve this problem? I'll read it first. A 1,500 kilogram automobile has a wheelbase, that is a distance between its wheels, of 3 meters. The center of mass of the automobile is on the center line at a point 1.2 meters behind the front axle. Find the forces exerted by the ground on each wheel. Okay, so I'm going to draw it first. So we've got basically wheel right here, and we've got the car. I'll just draw a kind of ugly looking car here, and another wheel right there. And we'll call this the back of the car, and this the front of the car. And the mass of the car is 1,500 kilograms. The distance between the wheels is 3 meters. So the distance from here to here, we'll call that D, where D is 3 meters. And the center of mass of the automobile is on the center line at 1.2 meters behind the front axle. So basically it's right here. I'll call that distance x, where x equals 1.2 meters, and that is where the center of mass of this vehicle is located. And the idea is we want to find the force exerted by the ground on each wheel. Okay, so I'm going to schematically represent this like this. And we've got a force due to the back wheels. I'll call that B. There's an upward force due to the front wheels. I'll call that F. And I'll also have a weight right here, and I'll call that W. Okay, and the idea here is for this to be in static equilibrium, the sum of the forces has to be equal to 0, and the sum of the torques has to be equal to 0. This implies the sum of the forces being 0 means that the center of mass is not accelerating, and the sum of the torques equals 0 means that the vehicle is not rotating around its center of mass. Okay, so let's first of all do this one. So in other words, the upward forces, B and F, have to be equal to the downward force, W. That implies that the sum of the forces is equal to 0. Similarly, the sum of the torques equals 0. We have to decide where we want to compute the rotational inertia, where we want to compute the torques about. So let's compute the torques about the center of mass. So we'll call any torque that's trying to make it rotate in the clockwise direction positive, and any torque that's trying to make it counterclockwise, we'll call that negative. Okay, and we know that the distance from here to here is 1.2. The whole distance is 3, and so this distance right here is 1.8. All right, so what are the torques? Well, the torque that's trying to move it counterclockwise is going to be B times 1.8. Well, let's just do this as a fraction, 18 over 10. And then the torque that's trying to move it counterclockwise is F times, well, 12 over 10, 1.2. And the sum of those has to be equal to 0. Okay. So now we basically have 2 equations and 2 unknowns. Well, this kind of nice right here. We can multiply this whole equation through by 10. So we'll get 18b minus 12f has to be equal to 0, or 18b equals 12f. Well, that's kind of easy. We can divide both sides by, divide both sides by 3. So we'll have 6b equals 4f. Well, we can still divide through by 2 then. So we have 2f equals 3b. Okay, so that's a kind of relationship between f and b. And now we can use this equation right here. B plus f is equal to the weight of the entire vehicle. So that's, well, what's the weight? It's 1,500 kilograms. And then you have to multiply that by the acceleration of gravity, which is 10 meters per second squared. And that is going to give you 15,000 newtons. Okay, so if we want to do this in newtons, that's what we have to do. So now we want to basically, let's rewrite these down here. B plus F is equal to 15,000, and B is equal to 2/3 F. So I have 2 equations, and 2 unknowns, so I can substitute this one in for right there, and I get 2/3 F plus F, which is what? 5/3 F is equal to 15,000 newtons, or F is equal to, we'll divide through by 5, I'll get 3,000 newtons, and multiply that by 3, and you'll get 9,000 newtons. So the front wheels are exerting a force, F equals 9,000 newtons, and the back wheels are just 2/3 of that, so the back wheels have to be exerting 6,000 newtons of force. Okay, so that would be the answer to this question. Again, how did I do this? Let's go through this slowly. If you have this vehicle and the center of mass is a little bit farther to the front, presumably because the engine is in the front of the car, then the front wheels naturally are going to be supporting more of the weight. How do we figure out how much more? Well, you take the sum of the forces as 0 and the sum of the torques is 0. The sum of the forces are 0, gives you B plus F equals W, and the sum of the torques equals 0, gives you 18B minus 12F equals 0. And you have 2 equations and 2 unknown, the rest is algebra, and we can just solve for the force on the front and the back. Just to double check, 9,000 newtons and 6,000 newtons is 15,000 newtons, which is equal to the weight of the car.